So with question number one, in the situation of a high profit industry and a low profit industry, the based on the situation, the prices in industry H are higher than in industry L. And then with part B, what that implies is that the value of output is higher in industry H than it is in industry L. So if you were to move that labor and capital, you would get a higher value good but lose a lower value good by decreasing that those units of output. And with part D, with two identical situations, when it comes to price, the costs in industry H or the higher value industry would be lower than that of industry L, and that implies that the amount of capital and labor required to produce one unit of output is less in industry H, or it simply requires fewer units of capital and labor to produce that one, or it's cheaper. And then with part F, in the situation where the capital is moved, you get more units of output in industry H than are lost in industry L by making this shift. And with question number two, because there is a higher return on investment, capital will flow from the pizza industry to the equally risky calzone industry.
All right, question three. In order to get the total cost for each company, you add up each of the marginal costs from this left table, and I put it right here. What is the cheapest way for them to make 11 tons? So the cheapest way would be for Big Co to produce 7 tons and Small Co to produce 4 tons. And in order to make 5 tons, Big Co should make 4 tons and Small Co should make 1 ton. This comes directly from the table right here. If you look at the marginal cost, the lowest marginal cost or the equal marginal cost would be the amounts they make. And what would their prices be? The prices has to be equal to the marginal cost. And from here, we can see the marginal cost for uh, 11 tons would be 40, and for 5 tons would be $20, um, or $10, sorry, in this case. Part D. Baco would be the low cost producer, and it would not be efficient for the government to close down Smallco because the total cost for producing any number of goods would be lower together if they produce a little bit of each than it would be to one company to produce all the goods. And to prove the statement right here, the total cost for Bitco to produce 7 tons would be $130. On the other hand, if Bitco and Smallco produce 7 tons together, the total cost would be $90, and the marginal cost would only be $20. Question 4. We're reviewing the elimination principle. So when the demand rises in industry X, the profits would also rise. And when profits increases, the firms and workers and everyone else would start to enter into industry X, and this would tend to increase the short-term supply. And over time, the supply and the profits would go back to zero. So that's how it happens, and then industry would start to exit.
So question 5 asks to fill in the table for an industry-wide marginal cost based off the two marginal cost functions. It asks to identify which firm produces the first unit and which firm produces the second unit of industry output. We can then use this information to fill in the rest of the table and make assumptions based off of the findings. So what we'll be using in this example is the invisible hand property 1, where essentially if one firm sets their price to be marginal cost, then this will have a trickle-down effect for other firms in the same industry. So we can see here that there's a function of marginal cost for firm number 1, and we can see another marginal cost function for firm number 2. So let's make a graph out of it. So we can see this table that says that a quantity of 1, the industry-wide marginal cost will be $6, and at a quantity of 8, oh, my bad. At a quantity of 8, the industry-wide marginal cost will be $18. Now this is because essentially production is being maximized through the efforts of both independent companies collaborating to minimize costs and maximize profits. So we can see that $6, of course, is produced by firm 1 because it is cheaper, and it makes more sense for firm 1 to produce, because essentially firm 2, it would be impossible for them to produce one unit at $6 effectively. We can then see that firm number 2 will produce an additional unit because it is cheaper for them to produce an additional unit than it is for firm number 1. We can then see this relationship go back and forth between the two companies, where one is continually producing the additional unit because it has a cheaper production cost. So this is why the progression looks like this. We can graph this relationship between quantity and industry-wide marginal cost with this graph right here, where we can see that the marginal cost growth is not exactly linear, but it does resemble linear progression more than a curve exactly. We can see that at a quantity of 1, the marginal cost will be $6. At a quantity of 2, it will be $9. And then again, at a quantity of 8, it will be $18. So we can see this plotted out on a graph very nicely. So thank you for listening, and I hope this expanded your horizons. Thank you. See you next week.
So question 6, part A, provides a series of equations to characterize an industry and asks, suppose 24 firms are in this industry, what is the equation for market supply? So this would be N times QS, so 0.12 plus 2.4 P. Then what is the equilibrium price and quantity? So you set the equations for QD equal to QS and solve for price to find $20, and then substitute that into the equation to find a quantity of 60. And the profit would be the revenue minus the cost, so that would be $20 minus 17.18, which is the average cost when solving that equation, multiplied by the quantity of 60, so $169.20 for each firm. According to the elimination principle, what should occur in this industry over time? So these above normal profits will be eliminated over time by entry into the industry. Part B asks the same questions as A, but with 35 firms instead. So using the same math as Part A, we find that the market supply equation is 17.5 plus 3.5 P. The price is $15, the quantity is 70, and the profit is negative $308.70. So according to the elimination principles, these below normal profits will be eliminated over time by exit from the industry. Part C asks, the elimination principle says that profits will be eliminated in the long run, so AC equals P. Using that fact, figure out how many firms will be in this industry in the long run. So P has to be the same as AC. So when solving for N, we set these two equations equal to each other to find that N equals 30. And then to check the work, I substituted that number N back into both equations and found that the price equals 17 and the average cost also equals 17, so this works out.